already noticed this. So if you look at these particular patterns, it's strange that a certain runner, and this is a 10 kilometer run, that sometimes he stops. So why does the speed go down and why does the heartbeat goes down? Well, it's logic why the heartbeat goes down, because you stop, and if you're well trained, immediately the heartbeat goes down. So that's a normal pattern, but we are interested why is he stopping. But it's even more curious, at certain locations in this diagram, and that's particular here, not only the heartbeat is not going down, actually the speed goes down, but the heartbeat is even going up. That's very strange, because that's not something you expect. And so, going back to this motto, discover the known, or see the known and discover the unknown, is an example. So you see the pattern of the heart stopping, heartbeat going down, that's what you expect, but you don't expect that you stop and heartbeat goes up. Now, let's see what's going on with this runner, and then we can look at the map. So I look at two particular situations. This is a detail of the first situation. So again, the speed is the upper one, speed goes down, heartbeat goes down. Why? Well, let's look at the map, and then you can see that the runner is at a crossing. So traffic might be the reason why he stops. Natural situation. Running up and down, it's a strange pattern there. Of course you can zoom in and then it's revealed. So what happens there? So here you have an unknown pattern, and with just the basic running knowledge, that's the knowledge from one domain, so to say, you will not be able to answer this question. So you need knowledge from another domain to support this and reason about it and find a solution. That's what I explained before in this diagram of information, insight, knowledge and reasoning. So this is such an example, and again realize this is a very, very simple example, just to illustrate this. Now, we should know a bit more about the running habits of this person, and it happens that this runner is always running with his dog. And this dog has also some habits because it's a hunting dog. And at that particular location, this dog was obsessed by this rabbit and ran off with the rabbit, and the runner was trying to call his dog. So he stopped, started yelling at his dog, became angry, and because of that, the heartbeat went up. Speed goes down, heartbeat goes up. So if you don't know about the social habit of the runner, not just the physics of the running, but also with whom he runs and what the characteristics of this, in this case, dog are, you would never find a solution. But now you can find a solution for this particular application. Again, you could map this type of data in the space-time cube. So the yellow horizontal is the map, and it's possible to move the map along the z-axis, along the time axis, up and down. And the whitish line is the space-time path, so how the location moved over time. Here you can see the details. So the map has been brought up to this location where the dog was, and here you can see the upper map just shows you the path, but in red in the bottom map it's the heart rate as an attribute of the path. So the thick line is the high heart rate, and okay, could be healthy when it's from running, but when it's from yelling it's maybe less healthy. So that's what you could devise from there. And again, you could depict it in different ways. So here I would like to end this particular lecture, and I do hope that by now you have an impression of some of the developments in cartography. They all relate to what we call geovisualization and geovisual analytics, and they bring our cartographic discipline a few steps further, but it also integrates them much more in the work of geoscientists who try to solve a problem and can work with advanced graphics to assist their own reasoning in solving their problems. Thank you very much for your attention.